The next is analyze data. We take data private complete as an example. According to the picture, it can be found that most of the test words are between 400 to 700. However, if we want to use BERT to train, we need to cut down the data because the capacity of BERT is 512. So we use 3 different methods to extract keywords: TextRank, TF-IDF, and CRF. And finally, we use BERT to train. TextRank is an extractive, unsupervised text summarization method. In our experiment, we set total length less than 50 for BERT to train, and we use 2 ways to do it: sentence extraction and keyword extraction. Although TextRank is good at sentence extraction, experiments have shown that in this project, keyword extraction works better. I think it may be due to the limitation of professional terms and total word count.
TF-IDF is a commonly used weighting technique for the information retrieval and the text mining. Therefore, we select the TF-IDF as our baseline and compare to other methods. And the figure is our process. And first, we use JBar to tokenize. And second, we use the TF-IDF to vectorize. And then we compute the cosine similarity between the 2 articles. And the last step is the compare keyword, because that the relevance of the 2 articles is asymmetric. So therefore, we use the crop chemical and pest keyword lists to compare and to determine the 2 articles is equal or greater or less. And the final result is 0.42.
Hello everyone, my name is Song Huaijun. I want to introduce the CRF BERT and the result of our project to you. The way I want to use the CRF and BERT is to challenge myself. So I want to use something new to finish the competition. And the first I want to introduce is CRF. CRF is conditional random field, which is that not only assume that the features are dependent on each other, but also consider the future of observations we are learning a pattern, that we can see the formula. The left part is a normalization, because the right side of the equation we have weight and features, but the output expected to be a probability, so need a normalization. And the weight and the features, that this component can be thought as a logic regression formula with weight and the corresponding features. And this is a chart that we can see how the CRF works. And the next one I want to introduce is the BERT. BERT is bidirection encoder representation from transformers. And I don't want to introduce more because everyone knows it. And I want to say that is why I want to use the BERT. Because firstly, that the BERT could only use a small amount of data, because I have only a small GPU to train the AI. I was afraid that it was hard for me to build a good one. However, the professor said that the benefit of the BERT is to handle text with a small amount of annotated data. And secondly, the limitation is I have to reduce the training data because it is hard for me to put all text into it. The capacity of the BERT is 512, so I could only intercept some of words instead of the text. And that is how the BERT works. And after that, I will introduce the experiments and the results. The first one is TF-IDF based BERT, and I use TF-IDF for data pre-processing and use BERT to train AI. And the right one is a confusion matrix, and the left one is a score. This is the loss chart, and this is the accuracy chart. And after that is the text rank based BERT. I use the text rank for the data pre-processing, and this is the confusion matrix, and this is a score. And the CRF based BERT is the same.